always been interested in space colonization. When I was a child, I was fortunate enough to see one of the last space shuttle launches, and since then my fascination with space has only grown. Last year, I was thinking about what would really be needed to create a long-term colony on the moon, and the first thing that came to mind was shelter. So, I set out to make a form of concrete that only used the resources on the moon. I succeeded in making a form of waterless concrete, or lunarcrete, and demonstrated that it may have practical use on the moon. This year, I wanted to continue last year's project by constructing a machine that would take the lunar regolith-based concrete and transform it into a viable lunar habitat. I decided that a 3D printer would be ideal for use on the moon because it is automated and it is able to create complex structures. I studied conventional 3D printers to understand more about the field before I started my design, and found that they all had three general design elements that I sought to replicate. They had a heated nozzle where the material was made liquid and then extruded, a motor which fed the material into the nozzle, and a tube which fed fresh material into the device. Armed with this knowledge, I set out to make my own extruder. I began with a general idea, a tube with an auger that would force the lunarcrete powder mix towards the nozzle. Right before the nozzle, it would be heated to its melting point, liquefied, and extruded. In order to heat the lunarcrete mixture, I attached 4 so-called cartridge heaters to the exterior of the tube, and tested them to find that I could get the tube up to 700 degrees, which was more than sufficient for the 240 degrees needed to make the lunar concrete. With the first design assembled, I tested it and found that although the heating and feeding tubes worked correctly, the motor was still too weak for the screw to move any concrete out. After replacing it with a stronger drill motor, it functioned well and could extrude concrete quickly and consistently. In conclusion, my lunarcrete 3D printer was a success, as it could extrude lunarcrete consistently. This is important, as it means my design can be used for the autonomous creation of structures on the moon, which is a big step forward in the field of space survival. However, before we get to that level, there are a few next steps that I need to do, primarily attaching it to a gantry system so it can work by itself.